Hello everybody, and welcome to example 1 on page 37. This is going to be our first example of taking a function and trying to find its derivative using the shortcut formulas that we just talked about in the previous video. Okay, so the function that they'd like us to look at is this, x cubed plus x plus 2 plus 3 to the x plus 1 over x squared. That's kind of a long function, and they'd like us to find the derivative of that. Okay, so the challenge here is going to be looking at those terms one by one and trying to figure out which shortcut derivative formula applies to each term. Okay, so I'd like to start by maybe just rewriting this function so we can get a good look at the terms one term at a time here. Okay, so we've got x cubed, and then we've got x, which is also x to the first. I'm going to write it like that because I think it'll make it easier to find a match for that. Plus 2 plus 3 to the x. And then we come to the last term, 1 over x squared. That is kind of complicated. It's a quotient, 1 divided by x squared. And if you look at our list of shortcut formulas, I don't see any formula on that list that involves a quotient, something divided by something else. So if we want to take the derivative of that last term, we're going to need to rewrite 1 over x squared somehow. And you can do that by remembering a little algebra fact. 1 over x squared can be rewritten as x to the negative 2 power. It's like taking that x squared and moving it into the numerator and changing the sign on the exponent. Okay? So there's our function rewritten, and what I'd like to do is to see if we can, term by term, figure out which shortcut formula would apply. Okay, and let's start with the x cubed term. Notice that that's x raised to a constant power. Okay, and so the formula that applies when x is raised to a constant power is formula 2, the so-called power rule. Okay, and let's just review what that says. So the power rule says if you start with something that looks like x to the n and take its derivative, you get nx to the n minus 1. If you kind of break that down into words, it's like you're taking the n that was your power, you're writing it down, and then you're going to multiply by x to a power that's 1 less than what you started with. So it's like you're bringing the exponent down, multiplying by x to the power of 1 less than what you started with. Let's see if we can apply that rule to x cubed. All right, so the derivative then of that first term by the power rule, we're going to bring the 3 down, and we're going to multiply by x to a power that's 1 less than what we started with. So we're going to get 3x squared. There is the derivative of the very first term. And then we come to x to the first. Notice that that's also x raised to a constant power. So that's going to be the power rule again. This time, the power is 1. And so we're going to bring the 1 down and multiply by x to a power that's 1 less than 1, which is going to be 0. Okay, let's see. Next term looks like 2. And so what happens if we take the derivative of 2? Do you see a formula on our list that would apply to that situation? Notice that that goes with formula 1, which tells us that the derivative of any constant is 0. 2 is a constant, and so we should get 0 when we take its derivative. Okay, next on our list is 3 to the x. Okay, which formula applies to 3 to the x? Okay, this time we've got a constant 3 raised to the x power. If you look up and down this list, hopefully you'll notice that that matches formula 3. A to the x. In our case, a is 3, and this formula tells us that the derivative is going to be a to the x ln of a, which in our case would be 3 to the x ln of 3. All right, and then finally, we come to x to the negative 2. Notice that that again is a power rule. We've got x raised to a constant power, and the power is negative 2. So there's the nx to the n minus 1 again. To take its derivative, we'll use the power rule. First step is to bring the power down, negative 2, and then subtract 1 from the power that we started with. Okay, and there is our derivative. Let's just rewrite it by simplifying a little bit. So we've got 3x squared, and then 1x to the 0. X to the 0 power is actually equal to 1. So that whole term turns into just 1. Okay, plus 0, we don't even need to write that, so we'll move on to the next term. 3 to the x ln of 3. And then finally, the very last term is minus 2x to the power is negative 2 minus 1. That's going to become a negative 3. Okay, and there's our derivative.